my pre-calculus students, how you guys doing? So I am going to do a couple of the problems from our notes, so just to show you how we would solve them. So this is part 2 of the solving trigonometric equations. So the first thing we're going to look at is solving quadratic trig equations. So we kind of treat them just like we would solve a regular quadratic function. So like problem number 1 where you have sine squared minus sine x minus 2, we're going to kind of treat that the same way that you would solve x squared minus x minus 2 equals 0. Okay, and so the way that we would solve this is we would factor and we would say x minus 2, x plus 1. So we're going to do the exact same thing, but instead of just an x here, it's going to be a sine x. So it's going to be sine x and sine x, and then it's going to be minus 2 and plus 1 because we want factors that multiply to give me negative 2 and add together to give me negative 1. So then we're going to set each parenthesis set equal to 0. So sine x is going to equal 2 and sine x is going to equal negative 1. So this one, is there anywhere on your unit circle where your y value is going to equal 2? And you're going to say, nope, that renders no solution because my y values are all between negative 1 and positive 1, so I'm not going to get any solution from that part. Now for this one, on my unit circle, is there anywhere where my y value will equal negative 1? And that's at 3 pi over 2. So we say there's one solution to this equation, and it's 3 pi over 2. All right, so for the second set, it's a little bit trickier because if you notice, there's a sine squared and a cosine x. So these two have actually different trig terms. So we're going to look at this and we're going to say, all right, could I somehow replace sine squared with something so that it's in the same format or the same trig as this? So I want to try and get it so that it's in terms of cosine. So because of our Pythagorean trig identities, we know that sine squared is equal to 1 minus cosine squared. So I'm going to replace sine squared with 1 minus cosine squared, and then I'm going to distribute in the 2, so I get 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. And then I'm going to combine like terms, so I get negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. And then I'm going to multiply everything by negative 1 just to get rid of that negative in front. So we get 2 cosine squared x minus 3 cosine x plus 1 equals 0. And now I want to solve, so I'm going to factor this just like we would if it were 2x squared minus 3x plus 1. So I would do my factors of 2, 2, and 1. So it's going to be 2 cosine x and cosine x, 1 cosine x. And then my factors of 1 are 1 and 1. And I want it to give me negative 3, so negative and negative. So I set each parenthesis set equal to 0. So cosine x is going to equal positive 1/2. Cosine x is going to equal positive 1. So at this stage of the game, this becomes a unit circle question. So we're going to kind of go back in our memories and say, all right, where does the x value equal positive 1? And I say the x value because it's cosine. So the x value on my unit circle is equal to 1 at 0. So there's one solution for there. It also equals it at 2 pi, but those are coterminal, so that would be kind of redundant if I said 0 and 2 pi. All right, so where does my x value equal 1/2? And my x value is going to equal 1/2. We're going to check out on our unit circle. And my x value is equal to 1/2 at pi over 3 and 5 pi over 3. So I have two solutions here and I have one solution there. So therefore, I have three solutions to this quadratic trig equation. All right, take a second and you try A and B.